Welcome to my channel. I'm Zhang Xu. Let's look at the problem 60 in chapter 23. Chapter 23 is about electrical potentials. There you can see we have four equal point charge Q. Q1, Q2, Q3, Q4 equals Q, right? And are fixed at the corner of a square. The side length is B. So this tells us R1 to R1 for R3 for R23 is B. Ask to find what is their total electrical potential energy. So in this case, if we want to find the total electrical potential energy, that means we need to find electrical energy between Q1, Q2, Q1, Q3, Q1, Q4, Q2, Q3, Q2, Q4, and Q3, Q4, right? Just as pairs of these four charges look like this one, right? And the next one, the distance Q1 with Q3, because this tells us its square should be equal to the distance Q2 with Q4 as squared B, right? This is a triangle. This is B. So the third side of the triangle is squared B. Agree? Now you can see you input the Q1, Q2, Q3, Q4, and the distance R1, R4, R3, 4, R2, 3, and R1, 3, R2, 4 inside. You get a function look like this one. And simplified, you get the answer there. The second one tell you, now we need to put the fifth charges Q at the center of this square. So the fifth charge is there. This is Q5, right? Can you find the potential energy is required? So that means the potential energy of the Q4 is due to the interaction between this Q4 with each charges with Q1, Q2, Q3, Q4. Agree? Now we can see the distance between Q1, Q5 is just square root 2 over 2b, right? Because this is just a half of this side length. And this side length equals, right? This distance Q1 with Q5 equals the distance Q2 with Q5 equals distance Q3 with Q5 equals distance Q4 with Q5, just square root 2 over 2b, right? Now you can see we can write the electrical energy there. You can see it is the charges, so Q squared divided by 4 pi epsilon naught times R, right? This R, we have four different terms. This is Q1, Q5, so this is the first distance. The second, Q2 to Q5, another 1 over R. And Q3 with Q5, another 1 over R. And the Q4 with Q5, another 1 over R. And then simplified, input R inside, you get answer there. The third one tell you if constrained to remain in that plane, is the fifth charge unstable or unstable balanced. So we can see this is Q5, right? We see the Q5 carries a positive charge. This is still Q. And the Q1 is still positive charge, positive charge, positive charge, and positive charge. If the Q5 moves a little bit close to Q1 and Q2, what will happen? There will be electric force to push it back to the center, right? Because they carry the positive, because Q1, Q5 are positive charges, so positive charges will repel it. So if the Q5 moves a little bit close to Q1, it will push back. So similar to Q2 with Q5, so Q2 will push it back. So always be pushed to its center. So this is called stable balanced, right? And next one, if the Q5 at the center carry negative charge Q, and we know Q1, Q2, Q3, Q4 are positive charge. You can see if the Q5 moves a little bit close to Q1, what will happen? It will be attracted to Q1, right? This is attract force because just the opposite direction. right? Because this is positive charge, this is negative charge. So that means if this Q file moves a little bit away from the center, it will be pushed too close to the boundaries Q1, Q2, Q3, or Q5. So this is called unstable ballast. Thank you.